Our transistor here, we know it does two things. We know it can act like a switch, and we know that it can also amplify current. Okay, so you may see a question like this in an exam, okay, where IC is our current at the collector and IB is our current at the base. And we were looking for the gain, so we're looking for our value here, okay, which is a ratio between our current at collector and current at the base. Yeah, it's defined as the ratio of the two currents. Okay, so whatever current we have here at our emitter will be 290 times the current that we had at our base. Now, how do we find this gain? Okay, so simple formula here. Here's a question. Calculate the gain of the transistor shown if the readings are at the collector, we have a current of 9 milliamps, and at the base, we have a current of 31 microamps. Okay, so this is 9. First of all, you have to convert it to its base, okay, in amps. So 9 milliamps is 0.009 amps, okay, thousandths of an amp. And 31 microamps are millionths of an amp. Okay, so you should have 6 digits. All right, 1, 2, 3, 4, 5, 6. 31 millionths of an amp. Okay, and if we divide these two, so IC divided by IB, we will get a value of 290. Okay, so that's our ratio between IC and IB. So whatever value current we have here should be 290 times our value of current at our base. Let's have a look at a simulation example here. Okay, so at our base, we have 31 microamps, and at our emitter here, we have 9 milliamps. Okay. So 31 microamps at our base multiplied by 290, which was our gain, gives us 0.00899. So we'll call that 9, all right? So it gives us 0.009 amps, or 9 milliamps, okay? There we go, 9 milliamps. So this 9 milliamps is 290 times our current here. So this transistor has given us a gain of 290 and multiplied our current by 290 times on the emitter here. Now, what if we had two transistors together? Okay. Well, if we wanted, we would do that if we wanted even greater current out. Okay. So two transistors together is very common. We call this Darlington pair after some person called Darlington who invented this, and it gives us a massive increase in gain on our emitter. Okay, so let's just run this here now. Now it actually is still one transistor because we still have 3 legs, you know. Actually, what I'll do is I'll get rid of that. Connect this collector to this one. So you see, we still have our collector, one base, and one emitter. Okay, so it's 2 transistors in one now. And we'll run that now. Okay, so we have a very small current, nanoamps here, going into our base. And over here we have 7 milliamps out here. Okay. So we have a massive gain here. All right. So we have millions of an amp over here, and this time we have 7 milliamps over here. So an even greater gain than what we had before. Okay. This here is called a Darlington pair, and it looks just like a normal transistor. All right. It might come with a little heat sink on it because they get a little bit hot. That'll keep it from overheating. There's our base, collector, and emitter, 3 pins down the bottom here.